Okay, so I think we're back. I have another question. Just give me one moment. I'm gonna tinker with some things here. We are, excuse me, going to take a look at another problem, another question, and that's going to be +1 linked list. So yeah, hello. I like how the sun is like right in my eyes, but there's blinds, so it's not completely in my eyes. Given a non-negative integer represented as a linked list of digits, excuse me, +1 to the integer, the digits are stored such that the most significant digit is at the head of the list. So this is the most significant digit. And so 1, 2, 3, you want to add 1, 1, 2, 3, 4, and 0. So number of nodes in the linked list in the range 1 to 100. The node values between 0 and 9. The number represented by the linked list does not contain leading zeros except for the 0 itself. Except for the 0 is the only one that has, okay. That's good. Alright, so just want to check something before we get into this. This is a pretty interesting question. I would say definitely, yeah, definitely. I've seen questions like this before. The thing about it that's kind of interesting is the carry on the linked list is significant. I would say you probably want to reverse this linked list and then operate on it and then reverse it again. And yeah, basically you have like a while loop, reverse, while loop, reverse, and then you're done. And the while loop is going to be basically it's going to be reverse, increment, and reverse again. The while loop is going to be such that you well, actually, you can do it recursively. I think that works too. Use a stack and yeah, you can do it recursively, I think. Okay, let's do it this way. Let's try this. This is easier. Do X. And I mean, I don't really need this, but yeah. So what we're going to do, and this is going to return a Boolean. We're going to say if not X, return false. Otherwise, int val equals X val. Val is greater than or equal to 9. It really should just be 9, but greater than or equal to is fine. And set the val to 0 and return true. Otherwise, return false. Otherwise, X val 0, val 2, val plus 1, false. Okay. So basically this is a carryover, and what we're going to say is these are the base cases. Okay, hold on. If not X, return false. Right. Base case. Otherwise, have this value. Yeah. So we say if f of x next, then we'll do this. Otherwise, don't do anything. I return false. Yeah, there we go. So it's a little confusing, but so what we say is we recurse on the next, we operate on the next node, right? If that next node and we recursively, if that next node returns true, meaning we need to carry, and then we're going to enter our loop here. And I want to say if x next and now the tricky thing is if it doesn't exist, then actually we want to return true. We don't return false. Yeah. So if we get all the way to the end, turns true, and we say, okay, take the value. If it's greater than or equal to 9, we're going to return true again. We're going to set that value to 0, return true again, and then we're going to go up the stack that way. And if you're not greater than or equal to 9, then you're going to update the value right then and there, return false, and that should return all the way up the stack until the end, until we're at the beginning here. Non-void function does not return a value. Oh, okay. I think that works. So we want to test 990. This is wrong, huh? Actually, there is a problem here. It's close. So, if this is true, then we actually need to get a new head, don't we? I didn't think about that. New head, we'll say. Or just list node. Yeah, just a new head. Next is going to be equal to, and you probably would need a, something like this. Previous head node. And then ret is going to this new head. Actually, you could even just do excuse me. Yeah, it seems right. Let's get some random inputs in there. Oops, did that wrong. I don't know. Excuse me. If I was this was during an interview, I think I'd be taking too long to do this. How do we do? 10 minutes? 11 minutes. That's not too bad. That's not too bad. A couple more edge cases to look at. Invalid test case. Alright. Got 0. Okay, so there's always going to be at least one node. I think that said that in the constraints. Yeah, 1 in 100. 0 and 1. Alright, looks okay. Let's see how we do. Hey, not too bad. Okay, so we got it. Yeah, I mean, that's one way of doing it. I actually prefer this over the reversing approach. I like this better. Reverse and increment and add a node at the end if there is none. Yeah, you can reverse, increment down the line, and each carry over, and then reverse again. You can do that. I don't really like that too much because it's reversing a linked list can be kind of a nuisance, kind of annoying. I know it's like a classic problem to ask in interview questions. They're really annoying. I don't like it. But yeah, reversing linked list is one thing. Reversing it and then applying this logic where you kind of carry over, you just go to the next node. However, you can do it. You do it the other way, or you can do it sort of without reversing the list by using a stack and kind of processing recursively first, and then from where that return value of that, you can decide what to do next. Which actually kind of is useful because you can push a new head into the linked list. Like, this is pretty simple logic. It's just the reason why I wouldn't prefer this is because it uses memory for the call stack, whereas the other approach would be probably be a little bit less efficient in terms of speed, but it would use less memory. So some things. Would also be iterative rather than recursive like this. Again, you could use a stack and just push things onto the stack instead of still do it iteratively. Although it's kind of like, anyway, okay. So yeah, thank you for watching. Hope that was interesting, and I will talk to you soon. Take care.